Today, we're taking our tech skills home with us and building our very own smart home. In this video, I'll be showing you how to get started using an awesome free home automation platform called openHAB. Welcome back to the Pro Tech Show and welcome to the smart home journey. If you're new, most of the content on this channel is for IT pros and decision makers. This one's for any tech enthusiast, but I'm going to make a couple of follow-ups where I take lessons learned in enterprise IT and apply them to home automation to increase security and all-round awesomeness, so get subscribed for that. The foundation for our smart home is going to be a free platform called openHAB. openHAB is self-hosted, meaning you install it yourself on your own kit. This could be a computer, a Raspberry Pi, or a home NAS. I much prefer this approach to smart home automation rather than buying some cloud-connected box from the store, and here's why. Number 1, it's my home. I want to be in control. Number 2, all of the tech I've invested in won't stop working if some company decides it isn't profitable anymore or they go out of business. Number 3, no subscriptions. I hate subscriptions. Number 4, reliability. I don't want my lights to stop working because the cloud farted or my internet dropped out. That's such a stupid problem to have. If you've not heard of openHAB before and are wondering what it is, it's just software. It isn't a physical thing. It connects two things like light switches. It supports literally hundreds of different smart home technologies. It's the brain that ties all of them together and runs our automation. You can install it on pretty much anything. It supports Windows, Mac, Linux, Raspberry Pis, other ARM-based platforms, Docker containers, even a Synology NAS. There's a lot of options and I can't cover everything, but I am feeling generous, so I'm going to show you two different ways to install it. A manual install on Windows and a repository-based install on Linux. You can use the video chapters to skip a version if you're not interested, although if you watch both it might convince you to try something new. Either is a good way of running it. Raspberry Pis are also very popular. If you want to go down the Raspberry Pi route, I'm going to point you at openHABian, which is a pre-built image to get you up and running. Check the description for links. Once installed, you can come back and join us for the configuration. For the rest of you, pick your poison and choose Windows or Linux. Now I know you're eager to get clicking buttons, but openHAB has changed a bit over the years, and both forums and documentation may reference older versions. To avoid confusion, here's a short version of the story. We're now on version 3. Version 1 was mostly command line and text files. Version 2 moved things towards a graphical web interface as the primary user experience, with some reliance still on the old text files. With version 3, there's a new web interface that covers pretty much anything you'll need to do, and it introduces a new semantic model for describing your home. All of these ways of using it are still valid, meaning there are often multiple ways to achieve the same goal. Different methods will appeal to different people, and different guides might be tailored to one or the other. I'm going to show you how to set up in the web interface using the new semantic model, because I think this is the best way for most people to get started. We've got our Windows machine and our Linux machine. You may need to adjust things slightly depending on your particular flavour of Linux. For reference, I'm using CentOS Stream in this example. I'm doing this at the terminal because openHAB only needs a minimal install, so there's no point loading it with a graphical interface that you're not going to use. If you've installed the GUI, that's fine. You can follow along from your terminal app. I am making an assumption that you have already installed an operating system. If you haven't and you don't know how to install Windows or Linux, there are plenty of videos out there, so I'm not going to reinvent the wheel. Go, watch them, and then come back because this one will be far too long otherwise. The first thing you'll need to do is install Java. openHAB runs in Java, and Java runs on everything, which is why you can run openHAB on so many platforms. You need to be using version 11 of the Java development kit, the JDK. If you simply Google Java, you'll probably land on the runtime environment. We don't want the JRE, we want the JDK. I will leave links in the description to make that easier to find. One thing to watch out for is that there are some known issues with the openJDK Java implementation that many Linux distros will install by default, and this can impact the stability of openHAB. On Windows, I'm going to install the official JDK from Oracle, and on Linux, I'm going to install the Zulu JDK, both of which are approved by openHAB. There's no rule that says you need to do it this way. You can use Zulu on Windows or Oracle on Linux if you prefer. To get the official Oracle Java development kit for Windows, you go to the website, link in the description, and scroll down to find Java 11. Then grab the Windows x64 installer. You need to create an account which I don't like. I would never encourage you to find a way around that, of course. The install process is mostly just a case of clicking the next button a few times, but pay attention to where it installs. If you didn't, have a look in Program Files, then Java. There should be a subfolder called JDK and the version number. It is possible to have multiple versions of Java installed alongside each other, so our next step is to tell openHAB which version we want to use. To do this, we create an environment variable. Just start typing environment variable into your start menu and you should see the option. Click the environment variables button, then under system variables click new and add a new variable with the name java_home. The value will be the folder where we installed it. That's Java installed in Windows. Let's do Linux. There are multiple ways to get hold of software in Linux, but the way I recommend doing it is by adding the repo and installing via your package manager, because that makes the entire system a doddle to update. I'll link to the RPM install guide, but you'll find Debian and Windows in the menu to the left if you need instructions for those. Copy the line to install the appropriate repository for your flavour of Linux. Now it's added and you can install Java. In my case, it's sudo dnf install Zulu 11-JDK. Let that run and we're done. Both our systems are ready to install openHAB. Back over to Windows, and the first thing we need to do is go to openhab.org, click download, select Windows, then the stable version. Milestone is a preview of the next version. It'll have newer features, but it hasn't reached final release yet, so you might have the odd problem with it. Snapshot is the current state of development. It's very much a work in progress, so it's more for testing and you shouldn't expect it to be reliable. I recommend sticking to the stable version. Click download and it'll arrive in a zip file. Installing it is simply a case of unzipping. In this case, I'm going to create a folder on the root of my C drive and dump it there. That's it, and I can start openHAB by running this file, start.bat. Once you see this openHAB text, you can get the web interface by opening a browser and going to http://localhost:8080. If you see this page, it's alive! However, we're not going to leave it like this, because right now I need to log on and run that start file to get openHAB running, and if I log off, it's going to stop. You probably want your home automation to be running all the time, so that's not particularly helpful. To remedy that, we're going to create a service that starts with Windows and runs in the background as long as the computer is switched on. There will be a link to the documentation for this so you can copy-paste. We need to go back to our command window and type feature:install service-wrapper, then wrapper:install, and we need to give it the short name, display name and description for our service. It doesn't actually matter what we type here because we're going to overwrite it in a minute anyway. This creates a bunch of files needed to install as a service, but they're too generic right now and not configured for openHAB, so we're going to shut down openHAB by typing logout and then go to edit them. The file you want is in your install directory, user data, etc. openHABwrapper.conf. And we're going to replace its contents with this from the documentation. Check the line up at the top here with openHAB_home in it and change it to match your install folder if you put it somewhere else. Save the file and open a command prompt running as administrator. Now type c:\userdata /openhab/bin/openhab-service.bat/install. Again, if you installed openHAB somewhere else, you'll need to change the path to match. Hit enter and we're done. To check it worked, find services in your start menu and you should find one called openHAB. Normally this will start automatically, but the first time, because we've just installed it, we'll need to click start. Go back to the web interface on localhost 8080 to check it's working. One final thing we want to do is open up the Windows firewall so we can access openHAB from other devices on the network. This isn't strictly necessary, you could always log onto this computer to access it, but that's kind of limiting, and the computer running my automation is stuffed away in a cupboard and it doesn't have a keyboard or a mouse attached to it. Back in your start menu, you want Windows Defender Firewall with Advanced Security. Select Inbound Rules and click New Rule. Select Port, leave it at TCP, then beside specific local ports type 8080. Click your way through the rest of the pages, give it a name, I'll just call it openHAB, and click Finish. That's it, you can now access openHAB from elsewhere in your network by opening a browser and pointing it to http:// the name or IP address of the computer, :8080. If you don't know the name, go back to your command prompt and type hostname for the name of the computer, or ipconfig for the IP address, and press enter. If you want to use HTTPS instead of HTTP, the default port is 8443. You can change the port numbers, and you can install a trusted certificate, but we'll be covering security in a later video, and regardless of what you choose now, do not put this on the internet. It's not ready for that. This is for local control within your home right now, and we'll address that in a later video. For now, that's us all done with Windows. Let's see how to install it on Linux, and then you can decide which you like best. You can download the zip file, but in Linux we can add a repo, which means openHAB gets updated anytime we update our operating system. Use a link to the documentation in the video description, as this will vary a little depending on your distribution. I'm using a Red Hat based distro, so it's a yum or DNF instructions I'll be following. That means I need to add a file in etc/yum.repos.d/openhab.repo and put this text in it. Again, I'm going to recommend the stable version of openHAB. When I save that file, I've added my repo, and I can install openHAB from my package manager. In my case, it's sudo dnf install openHAB. Most of the work to make openHAB run as a service in Linux is already done for us. The service is installed, and we just need to enable the option to have it start automatically. That's sudo system control enable openHAB if your distro uses systemd. To start it immediately, we use a very similar command, but instead of enable, we type start. Just like with Windows, we're going to need to enable a rule in the firewall to access this in the network. In this case, it's not optional because I haven't installed a desktop on my Linux computer, so there's no usable web browser on it. For me, the command is sudo firewall command --adds-port 8080/tcp --permanent. That will open up the port the next time we restart. To make it take effect immediately, it's sudo firewall command --reload. Now you can access openHAB's web interface from your network. Same again, http:// name or IP address of the computer, :8080. If you need to find those in Linux, hostname works in Linux too, and for the IP address, it's usually ipadd. If that doesn't work, try ifconfig. The first time we access openHAB will be treated to the setup process. The first step is to create an account. Then select our language and region. Next we can give it a precise location, which is useful if you want to link it up to weather information or use local sunrise and sunset times. I use this to tweak the control of lighting, for example. Then it asks us if we want to install add-ons. There are different types of add-ons to extend openHAB's feature set, but the most important type of add-on you'll want to pay attention to are bindings. That's because bindings are what lets openHAB talk to your smart home devices. Generally speaking, for every type of device you have, you'll need to install a matching binding to use it. This is as good a time as any to introduce openHAB's terminology to you, and the way in which things link together. It's important to wrap your head around this now, because it can seem confusing, but it's all pretty logical. As mentioned, bindings are used to find and connect to your devices. For this Wi-Fi connected LED strip, for example, there is a binding called Wi-Fi LED. Once I install the binding, openHAB will be able to discover and control it. The physical device is represented in openHAB as a thing. Things are your smart home devices. Each thing will have one or more channels. Channels are capabilities provided by the thing. In the case of my LED strip, it will have a power channel that can be on or off. Because this is an RGB strip, it will also have a channel for the colour of the light. In order to use these channels in openHAB, we need to link them to an item. The language is a little bit confusing because in English the words thing and item are often used interchangeably, but in openHAB they have specific meanings. A thing is a physical device. An item is a control within openHAB that we link to a channel in order to manage it from openHAB. Let's take the power channel from our LED thing. The power channel can be on or off. To control that in openHAB, we would create a switch item and link it to the power channel. If we change the switch item from off to on, it operates the linked power channel on the LED thing and the light turns on. So that's your bindings, things, channels, links, and items. Sometimes you'll come across a device that you can't connect to directly, like this Nest Protect smoke alarm. I can't connect to this specific device. I connect to Nest, and the smoke alarm also talks to Nest, so I control it via Nest using an app. In openHAB, this concept is represented by a bridge. After installing my Nest binding, I can add a bridge in the form of my Nest account. That bridge will discover things that the Nest account can communicate with. In my case, that's a smoke alarm, but could also be their cameras, thermostats, and doorbells. After that, it's the same as before. The things have channels, and you'd link the channels you want to manage to items in openHAB. Back to your setup wizard. For this demo, I'm going to install 3 bindings: the Wi-Fi LED binding, the IP camera binding, and the Chromecast binding. There is documentation for all of these over on openhab.org, by the way. Install them now, and that's us ready to start automating. We've logged in already, so if we look under settings in our administration menu, we can see things and items. If you haven't installed your bindings yet, or you want to add more in the future, you'll find them under here as well. We've already installed our bindings, so our next step is to add our devices. We go to Things in the menu and click the plus icon to create a new one. Here we can see our installed bindings that give us the ability to talk to different types of devices. Let's choose our Wi-Fi LED binding and try to find the LED strip. Once you select the binding, you will have the option to add the device manually. In this case, it needs an IP address and to know some details about the type of LED device it's connecting to. If you go back though, a lot of bindings have the ability to discover devices by running a scan, so let's do that. Some bindings will even find devices automatically without running a scan, which is why you may have noticed I had some in an inbox already. Back to our LED strip. It has been successfully located, we can click on that and give it a name to create it as a thing in openHAB. There we go, our very first thing. At this point we can click on it and start linking channels to items, but that's the openHAB 2 way of doing things. What I'd like to do instead is introduce you to the Semantic Model, which is new in openHAB 3. Back in our administration menu, then settings, and this time we'll click on the model menu item. This is going to introduce another layer of terminology, I'm afraid, and it is optional, but it lets you build a logical model of your home which adds much more context to devices as you add them. Despite sounding like extra work, it does actually make things simpler overall, as it hides some of the unnecessary detail and lets you arrange your devices in a logical way that mirrors the real world rather than a massive list of semi-abstract things and items. The best way to start is by defining the locations in your home. These are hierarchical, so we could start with one location for the ground floor and another for the first floor. Behind the scenes, these locations are stored of items as well, specifically they are group items rather than, say, a switch. The name field is an identifier and needs to be unique across all items. So to avoid conflicts and make it easier to tell what's what if you start rummaging through lists of items later, I recommend starting locations with a prefix like loc. The label is the name you'll actually see displayed and doesn't need to be unique. The category field is a bit misleading. All it really does is change the icon used in the interface. In the documentation you'll find a page showing all of the possible icons. Just enter the name of the icon you want as the category. In this case there is one for ground floor that seems perfect. The semantic class is a bit of additional context you can add beyond just calling it a generic location. Again, there's a ground floor option here that seems like a good fit. Click create and our model on the left has a ground floor. Now I'll add the first floor. Because this is a hierarchical model, I can add locations within locations. So I'll select the ground floor and click add location once more to add a location within the ground floor. Let's add a hallway and maybe a kitchen and a living room. Then a bathroom and a bedroom upstairs, and that's our house complete. Now that we've created this model, we can add our LED strip to it. Let's put it in the hall. Select the location and you'll see options for creating equipment and points. Equipment represents physical devices, and points represent properties of those devices. The simple way to think about it is that things translate to equipment and items translate to points. That's a good way to wrap your head around it, although it's not strictly true. Technically, the equipment is stored as an item as well, but let's not get into that. If you start off approaching it as things are equipment and items are points, it will make sense. And then inevitably you'll come to a scenario where it would be nice to break that model, and you can. For example, I have dumb motion sensors in different rooms that have been wired back to a single control board that adds smart capabilities, and openHAB sees the board as a thing with two sets of alarm channels. In the semantic model, I can instead choose to represent that one control board as two motion sensor equipment objects in different rooms, and I can put the relevant alarm points under each. The semantic model lets me build something that's more representative of the real world than the things and items approach can. We'll click create equipment from thing to add our LED strip to the hall, and select the LED strip thing we added to openHAB earlier. I'll pick light bulb for the category, and then for the semantic class there is actually a light strip one that fits pretty well. Now here we can see our things channels. If we tick the box next to a channel, we'll get prompted for some information. What's going to happen here is it will automatically create an item and link it to this channel. Then it will create a point from that item and add it to the semantic model. This is why I suggested not diving ahead and linking up items when we add the LED strip as a thing, because now openHAB will take care of it for us and will get included in the new semantic model with no further effort on our part. I'll select the power, colour and white channels. It's actually an RGBW light, so it has red, green, blue and dedicated warm white LEDs, which is what the white channel is for. Click add to model, let openHAB do its thing, and now in our hall we have an LED strip, and the LED strip has our chosen control points. I'll also add a camera to the hall, and I'll use our Chromecast binding to add a Google Home speaker in the living room. One of the nice things about adding these things to the semantic model is that openHAB will populate a few dashboards for you. If you click on the openHAB logo to go back to the home page, you'll see we haven't configured anything yet. But if we look at the bottom, there are tabs for locations, equipment, and properties. These provide ways of navigating your smart home using information from the semantic model. Of course, you can make your own layouts, but personally I find the location one to be a really natural way of interacting with it. And because we created our locations in the semantic model first, it's populated automatically for us anytime we add something. There are a couple of other ways you can build completely different types of dashboards by clicking on this Other Apps button in the top right. The ones that come out of the box are Basic UI and HAB Panel. Basic UI is kinda basic. Basic UI displays sitemaps, which you define in text files. It's a hanger-on from earlier versions of openHAB, but it's still used by the mobile app. If you want to use a mobile app, the layout is defined using a Basic UI sitemap. Other than that, there's probably not a lot of reason to use it anymore. The other option is HAB Panel. This is an alternative UI that lets you build custom dashboards designed to be displayed on a tablet as a sort of smart home master control panel. Some of these things can look pretty slick, I'll admit it, but I'm going to say something controversial. People waste far too much time on them, and I've been guilty of that in the past as well. These dashboards are not home automation. They're smart home visualization maybe. They're your showpiece, but they're not automation, because automation is automatic, and if you're pressing buttons then you're not automating. Let me give you an example. I'm recording this in my garage and there's a boiler next to me. If that fires up, you're going to hear it. I could build a dashboard with all of my heating controls and use it to turn off the heat in every room before I start. But what benefit is that really giving me over the built-in app I have anyway? Instead, I can set it up so that when I turn on the lights to my little makeshift studio and it's after 10 o'clock at night, openHAB infers I must be about to start recording and turns off the heating for me, and then turns it back on again when I'm done. These are the simple little automations that make life just a little bit nicer, and we can create them in openHAB using rules. You'll find them in the usual place under the settings menu, so let's build ourselves a little automation using this camera, this light strip, and this Google Home speaker. By the way, let me know in the comments what rules you come up with, because you can get really creative here. Plus icon to create a rule, and you get this nice little layout of when a trigger event occurs, then perform an action, but only if a condition is matched. There are multiple levels of complexity you can go to with this, but we'll start at the shallow end first. The camera has a motion sensor so it can start recording when movement occurs. We can tap into that using openHAB. We'll add a trigger using an item event. In this case, the item will be a motion alarm on our camera. You can see the devices are displayed using our semantic model, which is another reason it's worth taking the time to define it. I'll select the motion alarm and set the trigger to fire when the alarm changes from off to on. By the way, if you add multiple triggers, the rule will fire when any of them occur. It's a security camera, so maybe someone's breaking in. Let's give them a fright by turning on the lights and unleashing the dog. Add action, item action, I'll just switch on the power for our LED strip. As for the dog, there is no dog, but they don't know that. Add a second action, audio and voice this time, and then we'll play an audio file of a dog barking using our smart speaker. Now if my camera detects movement, the intruder is going to think they've been rumbled and they're about to be set upon. Except it could just be me walking to the fridge and that's going to get annoying, so let's tweak our rule a bit. One thing we could do is add a condition. I use a smart heating system called Tado, and it uses geofencing to decide if it needs to heat the house based on whether someone is at home or not. We could use that here to add a condition that our rule only triggers if nobody's at home. Another issue is that as it stands, it's going to turn on the lights and just leave them on. We could adjust that by replacing our simple turn it on action with a script. When we select the option for a script, you'll see several sub-options. There's a sliding scale of complexity and flexibility here. On the very low end of the scale, you have what we were doing before, just sending commands to items. Low complexity, but also pretty limited. On the high end of the scale, you can write your own rules using code. This is the most complicated way to do it, but also the most powerful. In the middle, we have this option to build a script using a tool called Blockly. Blockly lets you build a script by dragging and dropping pieces of a jigsaw together. It's not quite as flexible as writing your own code, but it has a much gentler learning curve if you're not used to programming. We'll use Blockly here to make a simple script. The first thing we want to do is turn our lights on, so we'll drag a block onto the page that lets us send a command to an item. The command is on, and the item is our LED power, which we can again select from our semantic model. Now we want to add a delay, then turn off our light. There are a couple of different ways we could do this. We could pause the script, but a better way is to set a timer and let the script continue. By creating a timer, we have more flexibility and can add a little bit of logic to restart the timer if the motion is detected again, so that light stays on until we've had a consistent period with no movement. For now I'm going to keep it relatively simple. We'll drag on a timer that reschedules if it's triggered again before it expires. After 2 minutes, do with timer, we'll call it camera timer. We need another block with the action, so let's grab another block for sending a command, and same as before, but this time we're sending the command off. Reschedule if triggered, and there we have it, a simple script to turn on the light and then schedule a timer to turn it off 2 minutes later, as long as the rule isn't triggered again in the meantime. Click save and we're good. We've got openHAB installed, a handful of items added, and we've built our first automation. That's gotta be worth a click of the like button. What you can do with this is constrained only by your imagination. But there's one other very important thing you need to know. You must not, under any circumstances, publish your instance of openHAB on the internet like this. Right now, it is open for anyone who can connect to it to take control of devices in your home. So it's only safe to be used internally within your home. You do not want that happening on the internet. No remote access. Don't let the password fool you, that does basically nothing. It's more of a child lock than an actual security mechanism. openHAB warns about this in the documentation, but I know not everybody actually reads the documentation, and frankly the suggested solutions are not that great either. Not by my standards, so before you even think about setting up remote access, make sure you watch this video where I take lessons I've learned from designing enterprise remote access solutions for businesses, and I apply those to openHAB to give you a secure method of controlling your home remotely. If you got here too early and I haven't finished that video yet, I'll let YouTube pick a surprise one instead, and you can subscribe to find out when it's ready.